In this video, we're going to talk a little bit about fraction operations, or operations within fractions. For example, multiplying two fractions together. If you have a over b times c over d, this is just equal to the tops multiplied together, a times c, over the bottoms multiplied together, b times d. So, as always, let's see a few examples outside of the algebra. Let's try 6 over 7 times 21 over 30. Now we're going to do this problem in two ways. The first way is I can just multiply straight across. 6 times 21, well 6 times 2 is 12, 6 times 1 is 6, so 6 times 21 is 126. And then on the bottom we have 7 times 30, which is 210. Because 7 times 3 is 21, and then we tack on a 0. And now I see that I can simplify a little bit here. I see that they both have an even number. I see that both numbers are even, so I can say that this is equal to 2 times 126 divided by 2 is 63 over 2 times 210 divided by 2 is 105. And then I can cancel the 2's, and I can say this is equal to 63 over 105. But further, I see that 6 plus 3 is 9, 6 plus 3 is 9, and 1 plus 5 is 6, 1 plus 5 is 6. So I know that I can simplify this further. 63 over 105 can be simplified because both top and bottom sum up to a multiple of 3. They must both be divisible by 3. So let's divide by 3 as well. If I divide the top by 3, that's the easier one. 6 divided by 3 is 2, 3 divided by 3 is 1. The bottom divided by 3 is a little trickier, so let's multiply up. 3 times 30 is 90. So I know that it's at least 30. And then how many more than 30? Well, 105 minus 90 is going to give me 15, so it's going to be 35. And now I look again and I say, is there anything else I can cancel by? Well, there is. Both 21 and 35 are divisible by 7. So I can say this new number is equal to 7 times 3 over 7 times 5. And in the end, we finally get 3 over 5, which was a lot of work. But with multiplication, another thing that you can do is simplify sooner. So let's see what that means. We had 6 over 7 times 21 over 30. Let's simplify right away. We can do something called cross-simplifying. We can say this is equal to 6 times 21 over 7 times 30, and now we can cancel out anything on the top with anything on the bottom. So what I'm going to do is I'm going to look at 6 and 30 and say, can I cancel anything here? Yes, I can. I can cancel the full 6, divide both top and bottom by 6, and on the top I get a 1, up here I get a 1, and down here 30 divided by 6 is 5. So I can say this is equal to 1 times 21, or just 21, over 7 times 5. And now I can go further, because I can also look at that 21 and 7. I can look right here and say, can I cancel anything there? And I can. 21 divided by 7. I can cancel them both by full 7s. So this becomes a 1. 7 divided by 7 is 1. And 21 divided by 7 is 3. So we end up with 1 times 3 over 1 times 5, which we all know is 3 over 5. So the problem gets much more simple if you cancel before you start the problem. If we want a simplified answer, we have to cancel right at the start to avoid dealing with bigger numbers. So let's do another example. Let's do 8 ninths times 18 24ths. And the best way to understand this video and the best way to understand any of the math we do throughout the semester is to pause the video and try the problem. And then when you hit play, you can watch through and see if you got the right answer, or see where you went wrong if you didn't. So in this case, we have the same thing. I see that 9 and 18 both have a 9 in common. So this 9 can just go all the way away. It can be a 1. 18 can turn into a 2. And now I see that 2 over 24, I can divide them both by 2. And to clean it up, I'll rewrite it. I have 8 over 1 times, I lost the whole 18 now, so I have 1 over 24 divided by 2 is 12. And now 8 over 12 is not fully simplified yet. This is equal to 8 over 12. So I can divide both top and bottom by 2 again and say that this is equal to 2 times 4 over 2 times 6, which gives me 4 over 6. I can do it again. This is equal to 2 times 2 over 2 times 3. And in the end, we get 2/3. So simplifying before you start the problem is much easier than just multiplying across. In this example, if we just multiply it across, let's see if I can do some quick math. 8 times 18 is 80 plus 64, which is 144. And on the bottom, 9 times 24 is 180 plus 36, which is 216. And those numbers might not even be right. You can check me on them. But then we would have had to go and simplify from here, which would have been a nightmare. So it makes a lot more sense to simplify right away. So let's do one more example. Negative 6c over 7ab. This time we have variables, but you'll see it's not much more challenging with variables. Times 14b over 5. Let's say 5c. So in this example, we're still multiplying fractions. So we can still cross-cancel. We can cancel anything that's on the top with anything that's on the bottom. So I'll start by saying, well, I'll switch colors. There's a C on the top and a C on the bottom. So they can just go away. There's a B on the bottom and a B on the top, so they can just go away. What else can I simplify? I see that I have a 7 here and a 14 here. I can divide both of them by 7. This goes down into a 1, this goes to a 2. And now, once I start to get jumbled, I do like to rewrite my problem to make sure I'm not getting lost. So what we have left on the top is negative 6 over 1 times a, and then that's times 2 over 5. And this is an a, not a 9. And now we look. I don't see anything else that I can simplify, so I can just multiply straight across. Negative 6 times 2 is negative 12. A times 5, 1 times a times 5 is going to be 5a. And that is what we're left with. And that is multiplying fractions. Now let's talk about adding and subtracting fractions. Adding and subtracting fractions. So when you're adding and subtracting fractions, you have a few steps. Step 1 is to find a common denominator. Common denominator. And I'll just breeze through the steps and then we'll talk about them with a few practice problems to make it easier. Step 2, identify whether you need to add or subtract. Whether you need to add or subtract. Because especially, say you're a person going to school for teaching and you need to take the praxis. If you ever have to take a math test for one of your, just in the future, if you take the GRE, the praxis, any of that, sometimes it's not clear whether you need to add or subtract. You really have to look at where the negative signs are, where there aren't negative signs, the order of things. And then after you add or subtract, step 3, which is always the last step in fractions, simplify. So let's look at a few examples. Let's start with 3 over 10 minus 11 over 15. So in my first example, I have a minus, so I'm going to be subtracting. I don't have common denominators left yet. Step 1 is to find a common denominator, so let's start with that. What would be my common denominator between 10 and 15? Well, I have a trick to find that. I just throw them into the division box, and it'll spit out the least common multiple. What do 10 and 15 have in common? They definitely have a 5 in common, and 10 divided by 5 is 2, 15 divided by 5 is 3, And do 2 and 3 have anything in common? It doesn't look like it. So all I have to do to find my least common multiple is multiply all of these together. 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. So I know I'm going to have a denominator of 30s. Now I just need to change my fractions. How do I go from 3/10 to something over 30? Well, what do I multiply 10 by to get up to 30? Or 10 times what equals 30? 10 times 3 equals 30. Multiplying the bottom by 3, so I multiply the top by 3. 3 times 3 is 9. And then I look to the right, and I say, what do I have to multiply 15 by to get up to 30? Well, 15 times 2 is 30, so I multiply 11 times 2 as well, and I get 22. Notice that I multiplied 15 by 2 and 10 by 3. If you're comfortable with the division box, it will always turn out like this. Your final numbers at the bottom, if you cross-circle them, you'll always end up with what you need to multiply by in a fraction. If that's confusing, skip it and just think about it. So we have 9/30 minus 22/30. 9 over 30 minus 22 over 30. And now when we're subtracting, I see that we're subtracting, and when we're subtracting, we keep the same denominator, and we subtract numerators. What's 9 minus 22? Well, 22 is bigger, so it's going to be negative. And then I just say, what's 22 minus 9? 22 minus 9 is going to be 13. So I get negative 13 over 30 as my answer. Let's do another example. Let's do negative 7/9 plus 7 over 15. In this case, I have 7s in the numerators, but I still need a common denominator. So I'll throw my denominators into the division box. 9 and 15. What do 9 and 15 have in common? A 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And 3 and 5 have nothing else in common. So I multiply all three of my outside numbers together, and I find my common denominator is 3 times 3, which is 9, times 5 is 45. And then I see that I will get 45 if I multiply 15 by 3. So I'll multiply 7 by 3, and I will get 21. And if I multiply 9 by 5, I get 45. So I'll multiply negative 7 by 5, and I will get negative 35. And we still have a plus sign. Now here's the tricky part in this one. You're not sure whether you should add or subtract, because we see an addition, but we have a negative sign. So negative 35 plus 21 is really the same as 21 minus 35. So I'll rewrite this as 21 over 45 minus 35 over 45. And then I'll do the math. I see 35 is bigger, so I'm going to end up with a negative sign. I know I have 45 in the denominator, and 35 minus 20 is 15, so minus another 1 is going to be 14 over 45. I look to see whether I should simplify or not. Can't divide them by 2, can't divide them by 7, so that must be a fully simplified answer. Now let's add some variables. Let's try 2 over x plus 3 over y. And again, feel free to pause the video and try this yourself. So, this time I have variables in the denominators, which is a little scary, but I'm just going to follow the same exact rules. I'll throw x and y into the division box and say, what do they have in common? Well, I don't know what they have in common. I know they're two different variables. They don't have anything in common that I can see, so all I see is that they have a 1 in common. So my common denominator is going to be 1 times x times y, or xy. So I know I'm going to have xy in the denominator plus xy in the denominator. And then I look at 2 over x, and I say, what's it missing? What do I have to multiply x by to get up to xy? I multiply by y. times y, so I'll multiply 2 by y as well. I get 2y on the top. And for the same reason, I have to multiply y by x to get xy, so I'll multiply 3 by x. And in the end, I have 2y plus 3x, which I cannot combine because they have unlike terms, all over xy. And that's my answer. So we will do one more problem, and I can't simplify here. One of the biggest mistakes you make in math, before I forget, one of the easiest mistakes to make is to say that I can cross off x here, y here, but that is absolutely not true, and we will talk more about that in the future. So this is as simple as we can go. So now we'll try one more example. We'll go with a challenging one. Let's say 3 over 8x minus 5 over 12y. Let's try this one. So, step 1 is find a common denominator. So I just throw my denominators into the division box, 8x, 12y, and I say, what do they have in common? Well, I know they have a 2 in common, but further I can kind of see that they have a 4 in common, because 8 divided by 4 goes evenly. 8 divided by 4 is 2, with the x attached still. 12 divided by 4 is 3, with the y attached still. And 2x and 3y have nothing else in common, so I can just multiply right across. And I get my common denominator as 4 times 2 times 3, or 8 times 3, which is 24xy, minus, and my other denominator is the same, 24xy. And now I say, what is 8x missing? Well, it's missing a y. I'm going to have to multiply by y, but I'm also going to have to multiply by 3 to get up to 24xy. So I multiply by 3 times 4, so I'm multiplying by 12. Oh, I'm multiplying by 3 times y, my handwriting. And so I multiply the top by 3 times y, and I get 9y. Or I just see that it's going to be 3y. And then I look over here, and I say, what do I have to multiply 12y by to get my common denominator? Well, it's 2x. So I multiply 5 by 2x, and I get 10x. And I end up with 9y minus 10x over 24xy. And again, I can't subtract them because I have a y and an x, so they're unlike terms, and I can't simplify because there's subtraction going on here. This is not multiplication, so I can't just cross off the y's and the x's. And that is all I have to say about adding, subtracting, and multiplying fractions.